Okay, this is going to be for number 11. And I know I kind of messed up on the number, and I should have changed that by the time I sent that out. Number 11, I think, is going to give people a little bit of trouble. So we're going to do this one together, or hopefully do it on your own and check your answer here afterwards. It says two conducting spheres have net charges of +4 microcoulombs and -8 microcoulombs and attract each other with a force of 16 millinewtons. The spheres are brought into contact and then moved apart to the initial distance. What is the new force between the spheres? Is this force attractive or repulsive? Holy cow. It is confusing. Hopefully you watched that last video. It's a little bit helpful. So if you watched that last video, it is crucial to know how to do that, to find this one. What we need to do is we need to find the distance between these two spheres originally, and then after that we need to figure out once they touch, what is the new charge of these, and then using the distance we found, and then using what the new charge would be, once these touch, we can figure out what the new force is between them. So, like the other ones, let's start out with our charges, or just writing down our known and unknown. We have a +4 microcoulomb, so that's going to be plus 0.1235 coulombs. 2 is going to be -8. That's going to be 1, 2, 3, 4, 5 coulombs. Our electrostatic force is going to be equal to 16 millinewtons. So watch out for this one. It is going to be 3, milli 3. It is going to be -3, but 1, 2, 3. So 0.016 newtons right there. K is going to be the same. And R, we don't know right now. That's what we're going to try to find. Right, let's pull up my calculator, make sure I have everything. So, let's see here. For the equation for the distance between the two objects, that is going to be dogs are going nuts. So we're just going to do that to find the radius. So if we do that, it should come out to 9 times 10 to the 9th times 0.000004 times 0.12345. Remember, don't worry about the negative for right now. You're finding the distance, at least. Okay. 0.016 newtons. And then all of that divided. So, if you do that, you should end up getting your radius as equaling 4.24 newtons. Okay. All right, so now we know our radius, but the rest of the question is saying, if the spheres are brought into contact and then moved apart to the initial distance, what is the new force between these spheres? So, if these two touch, one sphere +4, we got one sphere, -8. Okay, so in total, we have an overall charge, a net charge of -4, right? Because the -4 microcoulomb here is going to cancel out the +4 microcoulomb there. So we're going to be left with a total charge, once they're in contact, of -4, okay? but that is going to be distributed evenly then among these. So after they touch, like that, we are going to get one sphere with a -2 microcoulomb, and then the other sphere with a -2 microcoulomb, right? Because the -4 charge here cancels out the +4 charge. We're left with overall -4, and then that is distributed between these two. So our new equation after they are apart from each other, and remember that's going to be -4, right? So it's going to be -2 microcoulombs, or 0.12345. And then our 2 is going to be -2 microcoulombs, or -0.00000, so 5. 2 coulombs, and then everything else is going to be the same, except for electrostatic force, which is what we're trying to find. K is the same, and our radius, we now know, oh, that should be meters, 4.24 meters. Okay, well, let's see what we get. So, if we do that, three, 4, 5 times 1, 2, 3, 4, 5. It's going to make them positive anyways. All right, let's see what we get for that. We should end up getting for that roughly 0.002 newtons, and that is going to be repulsive. Okay, because now that they're both negative, right, it's going to be pushing apart from each other. So that is going to be our answer for number 11. A little tricky, just so you know, the answer key says 2 times 10 to the -3. Right, 1, 2, 3 newtons.